All right, in this video we're going to go through the solutions of the third homework sheet. So this covers 8E and 8F, which is two-step experiments and tree diagrams. Okay, so let's get into it. Question 1, a letter is chosen randomly from the word happy and a second letter is chosen from the word hey. List the sample space using a table. So I'm going to write it over here because I want to keep it for the questions later on. So we'll write happy at the top and then hey on the side. And then your sample space, we do the letter from happy first and then the letter from hey second. So we have HH and HE, HY, HA. Oops, what am I doing? Sorry. I might do that in a different colour just because I'm going to be writing a lot of letters. Okay, sorry, it should have been A first. So AH, AE, then AY. Then for P, PH, PE, PY, and I might just do Y while I'm here. Oh, it's terrible Y. YE, YY. And let's do the second P, PH, PE, and PY. Okay, so list the total number of outcomes. Okay, so remember you can just multiply the number of letters in each word. So 1, 2, 3, 4, 5 times 3 is 15. So total number of outcomes is 15. Let's scroll down. Find the probability that the two letters chosen will be H and then E. Okay, so we just look for outcomes that have H then E. So we've got 1. Okay, so it's just 1. So 1 out of 15. It's the same letter. So we've got 1 and 2. So 2 over 15. Not the same. So obviously that's going to be the complement of that. So all I have to do is say, well, 15 take away 2 is 13. 2 vowels. So we've got AE, that must be the only one. So 1 over 15. H and Y, so it can be HY or YH. So we've got 1, 2 out of 15. So for this question, the hard part was actually writing that sample space, but once you've got that, you can see all the different outcomes and answer your problem. So hopefully that was the last one. Good. Question 2. A fair four-sided die is rolled twice and the total is noted using a tree diagram to list the sample space, including all possible outcomes and their probabilities. Okay, tree diagrams can be very, very messy, especially if I'm trying to do it. Actually, I don't know where that's going to be. Okay, so we've got our different possibilities for the first one, 1, 2, 3, 4, and we're doing a tree diagram. So off each branch, I should have my 4 different outcomes for the second. Now I'm going to definitely run out of space here, but hopefully you get the gist of what I'm doing. So then you do the same for 3 and the same for 4. Okay, so 1, 2, 3, 4. And your outcomes, so we have to include all possible outcomes. So we should have on the end 1, 1, 1, 2, 1, 3, 1, 4, then 2, 1, 2, 2, and so on. Okay, so you should have 4 times 4, 16 different outcomes. Okay, so let's go down here. We're adding the total. Okay. So I should have probably added those up. So 1, 1, and the total is 2. Okay, so find the probabilities. So find the probability that the sum is 2. So you can only have 1, 1, and that is only done once. So it's going to be 1 over 16. Hopefully you've got the tree diagram there and you can actually read it straight from there. I'm going to have to just count in my head. All right, so the probability of 5, I know we can have 1, 4, 4, 1, 2, 2, and there's only 1, 2, 2 we can have. And is that it? Oh, not 2, 2, sorry. 2, 3. Let's had that 4 in my head. And then 3, 2. And that's it. Okay, so there's 4 over 16, which gives you 1/4. The probability of getting a sum of 1 is 0, and the probability of getting a sum that is not 1 is 1. Okay, so this is not at all likely, and it will definitely happen. Okay, so remember all your probabilities are between 0 and 1. Let's move on to question 3. Can I fit that all on? Okay. 2 people are selected from a group of 2 females and 3 males without replacement. Find the probability of selecting a female on the first selection. So if you want to do this, I would do it as a table. So you're selecting 2 people. So the first one can be female, female, male, 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 and then female, female, male, male, male. And remember, actually, let me just pause for a second. So I'm going to do this as a two-way table. I just realized I probably wouldn't do it as a two-way table. I would do it as a tree diagram, but let's do it as both. So here, female, if we had this female here, obviously we can't choose that female again. So I'm just going to put across there. And if we chose this female, it can't choose a female in the same spot. Okay, so you can go down like that. And then you can write all your possible outcomes. But like I said, I think it would be better to do a tree diagram. So I'm going to do this one on a tree diagram instead, just because it's going to take up a lot less space. Okay, so female, male, and then we can have either female or a male, female or a male. So the probability of, if we already had a female, so we have, let me just check, 2 females, so we've got 5 people. If we've already chosen a female here, that means we've only got 1 female left and we have 4 people. So if you think about it, let's write the possible outcomes. If I've already chosen a female, that female is now gone. I now have 1 female left out of 4. Now, if I've already got a female here, so that female goes. The number of males, 1, 2, 3, I still have 3 over 4. Now, you've got 1/4 here and 3/4 here. In a tree diagram, your branch should add up to 1, so you can always check whether you're correct. All right, let's put this female back. Actually, I'm just going to rub it out. It's going to look messy otherwise. Okay, so we'll put that female back in. This time we've got a male who was chosen. So the female is 2 over 4, which is a half, and then a male is still 2 over 4. And you can check to see that that does add up to 1. You can simplify that to a half if you like, but in probability, it's sometimes easier just to leave it as as unsimplified until you get to the end. Okay, a female on the first selection. So we have 2 out of 5 females. I think that's a male on the second selection, given that the female is chosen on the first selection. So this is a conditional probability question. So male given female. All right, sorry, I just had to pause, so I don't know what I was talking about. All right, probability of male given female. So instead of, you don't use the conditional probability formula here, but that's the same notation. So if we know that a female has already occurred, what's the probability that we're then going to get a male is 3/4. Okay, so we know the female was definitely the first selection. What's the probability of getting the male on the second? It's 3/4. The probability of 2 males, so we've got M and M. So the probability of MM. And if you want to list all your outcomes, we have FF, FM, MF, MM. So the probability of getting the first male, and maybe I should put this branch here. So the probability of getting the first female is 2/5 and the male is 3/5. So you just multiply along your tree or your branches of your tree. So for the first male, it's 3/5. And then for the second male, it's 2/4. And I'm going to simplify that to 1/2 just to make it easier to multiply. So 3 times 1 is 3, and 5 times 2 is 10. The probability of 1 male. So we just want 1 male. So we can have FM or MF. Sorry, I keep checking the answers just to make sure I'm doing it right. So the probability of 1 male, we can have either FM or MF. So the probability of FM first, remember we go along the branches, 2/5 and then 3/4. And then we add the other possibility of MF. So 3/5 and then 2/4. Or if you want, you can simplify that to 1/2. Okay, so we've got 2 times 3 is 6, 5 times 4 is 20, and then 3 times 1 is 3, 5 times 2 is 10, and then we can simplify this to 3/10, so it's going to be 6/10. And then that can simplify to 3/5. Okay, so a little bit of working out for that one. And at least 1 female. So basically, if we want at least 1 female, we want everything except for 2 males. So we've already done the 2 males here. So I can just say, well, it's the complement of that, which is going to be 7/10.